So how's it going? Everything okay? Good, good, good. The nice weather's coming back. It's been great to see the sun again after all of that rain. So let's just get straight to it. Today we're going to start covering arrays. So just to sort of summarize what we've done so far, we've gone through all of the control structures that we need to program. If statements, so those are statements that allow us to skip code. While loops, which are statements that allow us to repeat code, possibly forever. And for loops, which allow us to repeat code, but only a predictable many times, right? So we sort of needed both, right? One for possibly indefinite and one for possibly finite. So these are all called control structures because they allowed us to control the sort of execution flow of lines of code. Today, we're going to introduce something called a data structure. That's like a more sophisticated thing than just sort of these variable names that we've been using. So far, all we've been able to do is put like numbers and give them things like names, like X gets 4. The most basic type of data structure is an ordered sequence of numbers, or really anything that we want. But for us, it's numbers. This is called an array. Now, you probably already encountered something like an array in your maths courses. Okay. Have you taken linear? Does the word vector mean anything to you guys? So a vector is just an ordered sequence of elements. And an array in Python is essentially just the analog of a vector for a programming language. So if you can just grapple with that, it's not going to be overly difficult to sort of like put stuff into an array. But I just want to show you then like how we're going to use them in practice, which can sort of get a little bit more tricky. Okay, so here's the motivation. So here's a question that currently we don't have the tools to cope with. If I were to say, write me a program that asks the user to enter an arbitrary number of numbers until the user hits stop and ask you which number was inputted most frequently, we can't, we don't have enough tools to answer this question. So this is the motivating question for sort of introducing arrays, with the caveat that I'm not actually going to introduce enough stuff today for us to be able to cover this, like to actually solve this question, unless there's a lot of time at the end of class, because I technically have to show you appending, which will come later. So I just want to focus on the absolute basics today. Okay, step one. In order to use an array, you have to import Pylab, right? So we should just be importing Pylab as a matter of habit at this point. So here it is. I'm going to execute it. So now we have access to the array data structure. There is a typical way of naming things, right? So we want to make sure we're using descriptive variable names. Now, when we're using arrays, it's typical to pluralize your name. Like rather than having student, you'll have students. Rather than having a date, you have dates. I'm going to be sort of lazy. Like I use the variables X, Y, and Z usually. And today I'm going to be using variables like X's, Y's, and Z's. But this pluralization of a name is useful to indicate that the name is holding something which is a sequence, right? That's why it's a plural. It's many things. Just be careful to not use the variable as, because as in Python is a reserved word. And the reserved words we're not allowed to use as names. Like we're not allowed to have a variable name called while or if. And for the same reason, we can't use as. So just keep that in mind. I usually use X's, Y's, and Z's. Okay, so I'm going to show you a variety of ways that we can simply create a list of objects. Here's one, and probably the most easy way of doing so. And that's just to like explicitly state what you want in the array. Now be careful. So this array actually contains something in square brackets, right? So we don't really use the angle brackets here for vectors, but square brackets. So there's sort of double bracketing here. You have to make sure that you include. So if we can say X's is an array, round braces, of the ordered elements 11, 22, 33. And I'll just execute this and we'll see what spits out. Right, so it's spitting out this, right? So rather than having angled brackets for an array, we sort of get these square brackets to indicate an array, and you see these gaps in there. And sometimes these lists get quite big, and it's nice that they sort of get printed to the screen in a nice way. I'll show you what that means. Here's another way that we can create an array. So notice here, this was an array of 3 elements. Our arrays always have to be created in such a way where we're telling it exactly how long the array is going to be. All right, so I'm saying in this instance, hey, Python, give me an array with 13 zeros in it. And there we go. We have an array with 13 zeros in it. You can also say, give me an array with 130 zeros in it. Oops. Well, it sort of tries to print out nicely. I think maybe my browser is too zoomed in to do it, but typically it'll be nice, right? So we can explicitly put stuff into an array. We can have the array full of zeros, which is called zeroing out an array. And we can also fill an array with ones. That should be ones. Why isn't it ones? Because I put y's there and not z's. That's better. Okay. So we have an array of 13 zeros. We have an array of 13 ones. And each of these are going to be useful for various reasons. Finally, we can use, remember last week we were talking about range. So range was something that allowed us to sort of generate a sequence of numbers, starting from a left endpoint, inclusive, going to a right endpoint, exclusive, and stepping by some certain step size. So let's just play with this. So I say I have a left endpoint of -5, a right endpoint of 2, and I want to step by 3s. Okay, so what's the first number that's going to be put into this array? I want to go from -5 inclusive to 2 exclusive and step by 3. -5 is the first. What's the next? And what's the last? Is it 1? Well, let's check. -5, -2, 1. So just keep in mind that this is a little bit different than range. This one's called a range, right? A is for an array, right? So instead of getting a range, which is something that we use for a for loop, a range acts almost identical to a range, except in this case, we're going to get back an array. It's like, so we can continue playing with this. Like we may want to start from 0 and go to 10 and increment by 1, right? This is going to be very predictable. What's the first number and what's the last number? First number is left inclusive 0. First number will be 0. Last number will be 9. Perfect. Thank you. So 0 through 9. How can I generate this backwards? How can I go from 9 to 0? Yes, sir. Okay, let's see. Perfect. Good job. No worries. Someone give him a pat on the back. So you see, like we have some provisions for setting up arrays and putting stuff in them. Like if all else fails, you can just set this up explicitly. But if I said something like, right, put the first 1,000 even numbers into an array, like I think doing it explicitly wouldn't be that great of an idea. So we're going to get quite a bit of leverage out of this a range function. Okay, so we have this array. We can give it a name like B's or X's or Y's, but that's like representing the entire list. How then can I like access elements of the list? Well, in sort of linear algebra, the individual components of the vector or the individual components of our array are called the elements of the array. And since this is an ordered sequence of elements, the sequence can be numbered. Now, the thing that's important for us to remember is that mathematicians and computer scientists start counting from 0. We don't start counting from 1. So therefore, the first element of a list has index 0. And the last element of the list is going to have index the length of the list -1. Right? So this is precisely why we set up our ranges to be right exclusive, because we'll often want to say, walk through this list for the range length of the list, but don't try and access the list element at the length of the list because something bad will happen. So let's just study this example. Here's an array called x's, which I've just sort of loaded in explicitly with 3 numbers, 11, 22, 33. I'm going to print x's has length len of x's. So this is how you ask for the length of an array using len. I'm going to say x is at 0 is equal to x is at 0, x is at 1 is x is at 1, and x is at 2 is x is of 2. I'll just do this, right? So you can see x's has length 3. X's, the element at x's at the position 0 is 11. The array x's element at 1 is 22. And the array element of x's at index 2 is 33. Okay, so this begs the question, what happens if we try to like access a member of the list that doesn't exist? Well, you're going to get an error. We often generate errors when programming in any type of language because it's hard. Index errors especially are thrown all the time because you essentially just have to miscount by 1, right? So even professional programmers will throw these index errors, but I'll just show you. So here's our array. It has length 3. Therefore, x is at 10. Like there is no element in this array at the 10th position. So if we try to do this, it's going to say, sorry, like you get an index error, right? There is no element at index 10. What is the minimum length of an array that will allow you to access its 10th element? 11, right? Because remember, we start counting from 0. Like this is the other reason it can often get a little bit troublesome when this is why you're going to throw index errors, right? Because of the 0 indexing. To make matters worse, some programming languages don't 0 index. Most programming languages do, right? Python certainly does. So just remember, start counting from 0. The other thing that you may encounter is that, like, does it make sense to ask for what the index at like 1.5 is? No, right? So you can't ask the array for an index at a float, right? Anything with a decimal. Like there is an index at 1, but Python simply is going to reject any float, like period, right? For the same reason, we can't ask like, what is it at the index 1.5, right? Python is just going to say, to simplify things, like just don't give me floats, right? When you give me an index, I'm going to insist that that index is like an integer. So I'm going to do this, and it will say index error. So that's not very informative, but essentially this is because you're indexing with a float and not an integer. Now, I said integer, so this begs the question, aren't some integers negative? Well, there's a really useful feature of Python where you're actually allowed to index from the front of the list and you're allowed to index from the back of the list. So we can actually say, so here's an array, I'm going to put 3 things in it, 11, 22, 33. And I can say, give me x's at position -1. Right, so this is counting backwards through the list. So if this is position 0, 1, and 2, moving backwards, this is position -1, -2, -3. So let me just run that. Right, so you see you're indexing positions now backwards, which is very useful sometimes if you want like the last thing in the list. Of course, if we ask for the position at -4, like this is going to throw an index error, right? There is no element at position -4. How long does a list have to be in order to have a list index at -4? 4, right? So because we can't really 0 index from the back, like what's -0? It's the same thing as 0, right? So when we're moving forward, we start at 0. When we're moving backwards, we start at -1, right? So just be careful. As I said, if you throw an index error, don't sweat it. Even the most seasoned programmers throw index errors all the time. Okay, now that we've set up an array, we may want to, or in fact, we will want to go through that array and look at every element in the array. Right? Suppose we want to count something in the array. Suppose we want to sum the numbers in the array. Suppose we want to like permute the numbers in the array somehow. We're going to need some way to walk through them. So I'm going to put into X's an array of numbers that start at 0 and stop at 20 exclusive, counting by 3. So the first number in X's should be 0, and the last number should be 18, I believe. So what are the components here for walking through the array? Well, I'm going to do this in 3 ways. I'm going to do this using a while loop, using an index. I'm going to use a for loop with an index, and then I'm going to show you that we don't actually require indexes using a for loop. So the pieces are as such. So here's my array. I want to walk through it, right? So I want to look at every sort of element at some index. So this k is going to be the index. I usually use k as an index variable. I want to start k at 0 because that's the first position. I want to increment k by 1, right, each time I'm in this loop. And I simply want to say, in this instance, just tell me what the array element at position k is. So let's just look at this, right? So this is saying, like, we'll walk through this, exactly what Python does. Into X's, load the array of numbers starting from 0, ending at 20, right, exclusive, stepping by 3. So you can see 0, 3, 6, 9, 12, 15, 18, right? Let's just print X's as well, so you can see that it's there, okay? 0, 3, 6, 9, 12, 15, 18. Then I'm going to say, okay, I want to start looking at each of these elements in turn. So let's start at 0, because that's where the first one is. I need a stopping condition on my while loop. We always do. Otherwise, the while loop is going to run forever. The stopping condition is don't let k equal the length of the list, because there is no element in the array at the length of the list of the array, right? Because we start at 0. The last element in the array is at length of X's minus 1. Here I simply have a print statement, and then I increment the counter. Whoops. Are there any questions regarding this? Because I want to move stuff around and ask what happens. And this is just a very simple for loop. It's just taking k and incrementing it by 1. Okay, first complication. What happens if I put a less than equal here? What's going to happen? What kind of error? Index error. Why am I getting an index error? How does this change things? Like, this worked, this doesn't. Well, because the last value we're allowed to access is at 6. So when k is 6, this is fine. It will print out the element at X is at 6. Then k will become 7. 7 is less than or equal to the length of the list. And then we'll ask for what element is at the array position 7. And there's not, right? The last element was at array position 6, okay? So this is the first thing that you have to really be careful about. Use less than, okay? What happens if I switch lines 5 and 6? What happens now? There will be 2 effects here. Yes, sir. We won't print x0, right? Because the time we get here the first time, the k will already be 1. And what's the second thing that's going to happen? Well, I'll show you and then we can investigate. I still got an index error. Why? I've corrected that thing from the last mistake. But what happened now? Yes, sir. Yeah. So exactly, right? I am incrementing k before doing the list access. I should do it after, right? So when k gets 6, like we can access the array element at 6, but when k is 6, I make k 7 before checking this. So instead of going from 0 to 6 by permuting lines 5 and 6, now I'm actually accessing 1 through 7. Right, so remember, the first thing I said was crucial about programming languages was sequencing. And in that, permuting the exact same commands are going to produce different types of outcomes. So just be careful. There's like a myriad of ways things can go wrong with walking through a list, and it's usually index errors. So make sure you're incrementing your k at the appropriate time, and make sure you're not walking too far. Now that I said that, you really shouldn't be walking through arrays using a while loop. This is exactly what for loops are for. So what did I say was the difference between a while loop and a for loop? What are while loops used for? Like I said, there are two types of repeating we have to do. One type of repeating is when we may want to repeat indefinitely. And another type of repeating is when we know exactly how many times we need to repeat. Can we have an array that's infinitely long? Well, no, your memory is not infinitely big. Therefore, like a while loop is never required to go through an array. Arrays are always finite. Therefore, we can predict how many of these k's we need ahead of time. Thereby, it's actually much more appropriate to use the for loop in this case. We never used to teach for loops in this class. I pushed quite hard to have them included because it's going to simplify walking through loops in the following way. Right, so I showed you how everything can go wrong. This is how we can walk through an array using a for loop instead of a while loop. And in this case, like the benefit here is that first of all, the indexing, the incrementing of k is handled automatically. And we just have to like specify what range we want here, right? So I say, okay, so here's the same array, x's. I want to go from 0 to 20, increment by 3. We learned last week how to use range, right? So we give it a left endpoint, we give it a right endpoint that's exclusive, and we increment by 1. So I say I want to go from 0, like I want k to start at 0 and go to the length of the list exclusive. Can you see why now we set range up like this to be right exclusive? It's for exactly this reason, right? Because we want to exclude the length of x as the right endpoint because we're 0 indexing. Like this is actually really great behavior of range. It's like helping us not throw these index errors. And I just want to move by 1. And if I do this, we get the same outcome as we do before. Now, in reality, it's even more simple than this, right? Last week, there was a question asked about, do we have to include all of these numbers? And I said, no, but for simplicity, let's just assume that they're there. And we'll continue using all 3, but I just want to show you something. If you only put one number there, that one number is presumed to be the right endpoint. Right? Range assumes the left endpoint is 0. It assumes you want to increment by 1. So this actually makes it quite simple to walk through an array, right? Sort of, if we were using range in all the available ways we can use it, this ends up being the simplest. And you can see here that this is a lot easier than doing what we had done here. There's like way less to screw up, right? I just say for k and range lengths of x's, do the following. Okay, so this is necessary if you actually require the index. If we need to just sum the elements of a list, do we really need the indexes of the elements? Not really. What we really need is just to look, we need the indexes in order to like get the values themselves, get the elements. A for loop actually will let you walk through an array and just give you the values back, right? If you don't really care about the indexes. So there's like a further simplification that we can make here. And it sort of drives home the point of like why I'm pluralizing my variables, because you can get nice statements like this that like read very much like English statements. I'm just going to load into X's the range from 0 through 20, counting by 3. And now I can just say a very simple thing. I can say for X in X's, just print X. And there you go. Right? It's just gone through the array for us, indexing automatically and just giving us the values. Right? So we can't actually throw an index error. We're not even indexing in this case when walking through a for loop. Okay, so we can walk through for loops using while loops and a index counter. That's the worst way, but you should still know how to do it. And I still wanted to show it to you because in truth, like the for loop is just extra. It's just an extra data structure, extra control structure that we introduced to simplify things. The reason it was never included in this class before I pushed for it was because the philosophy was, well, the other stuff is just extra. Like, why don't we just stick with the while loop and not teach these extra things? But I feel that these are very helpful control structures because these index errors are very common. So you don't really have to engage with the for loop. I just recommend that you do. Okay, so there you have it. I've just shown you how to use an array, sort of define one, access elements from it, find its length, and traverse it. That was sort of easy. What's more complicated, or the way that we're actually going to learn, is by writing programs, like solving problems. So I have a bunch of exercises now that we're going to try, and hopefully you can like walk me through trying to solve them. Right? So we'll try to solve these together. Here's the first one. Fill an array called X's with 100 random numbers between 0 and 6. How necessary is the F before X? Absolutely necessary. It's a formatted string. It ensures that the there's a question from the chat. Okay, so side note, here's X equals 2. And one way, so I like to say something like this. I like to say X is equal to X. Right? And that produces something like that. This isn't in your book. In your book, it would say you'd have to do X is equal to comma X, something like this. But I don't like that because it gets kind of messy if you want to do like multiple things. So I could say something like X is equal to X, Y is equal to Y, right? And produce this. Whereas using your book's way, you'd have to say X is equal to, what just happened? My settings? X is equal to X and Y is equal to Y. And you end up generating these like really long things. You can do it this way if you want, but I just feel that it's not that sort of difficult to do this. But to me, this is more descriptive of what's actually happening. I'll show you one extra cool thing. You certainly don't have to do this, but Python actually will automate this. You can just put this and it will automatically dump those numbers in. This formatter is for debugging stuff. Anyways, this is just like a fancy extra thing if you're interested in some of these other tools, but it's okay just to focus on like the core basics. Both essentially have the same outcome. It will be useful once we start generating plots, because I want you to be able to automatically name your like title stuff. Okay, so one extra point. Have we covered strings yet? Like hello world? Right, so this is like an extra type of thing. We have integers, we have floats, and we also have like a provision for storing words themselves. And these words are arrays, right? They're arrays of characters, right? This is an ordered sequence of letters, right? So we can do stuff like this. Oh, L. Sorry. Don't ever use L as a variable name because that stuff like that happens. Yeah, so we can have arrays of letters, and arrays of letters comprise something called strings, and these strings are going to become quite useful later. And using the string formatter, like this just isn't used for printing. This is actually used to generate strings themselves. Right, so this is going to help us do something like automatically give your plots titles automatically, which I think will be very neat. But we're going to do that all later. Back to the task at hand. Fill an array called x's with 100 random numbers between 0 and 6. Sorry, 1 and 6. There's no 0 on the dice. Okay, you tell me what I need to do. How can I generate random numbers? Well, since it's technically not part of the curriculum, I'll just tell you. But recall, I can say from random, import random integer. So random integer is the function that's going to allow us to generate random numbers between 1 and 6. Right, so 1, 4, 5. Okay, so I'm generating random numbers. So what do we need to do here? So I need to fill an array. So what do you think the first thing we need? We need to declare an array. So how can I get an array of 100 positions? Should I do something like this? No, not a good idea. What are the other ways that we can spin up arrays? Yes, miss. A range, sure. What should I put in it? Doesn't really matter, eh? Okay, so I'll go from 0 to 100 by 1. And I just want to confirm, let's just be very careful that this is 100, right? Because of indexing. Okay, great. So it's 100. Right, there they are, the first 100 numbers starting from 0. Okay, so we now have an array. It has these numbers in them, but who cares? We're just gonna like overwrite them with random numbers. Okay, so now we need to loop. What loop should we use? While loops or for loops? Do we need to loop an infinite amount of times, or do we have to loop a known many times? Well, how many random numbers am I going to have to generate to fill a list of 100 boxes? 100. And is that finite or infinite? So which loop? For loop. Okay, so we want to have a for loop. And we want to say maybe for k in range. So we want to start from 0. We want to go to 100, right? Because this is going to do 100 things. We're going to get we want to go from index 0 to index 99. I want to increment by 1. And I want to then access every member of this list. And so I'm saying the array position, right, at k, you can think of these as boxes. I'm go to the kth box, and the kth box of x's gets this random integer, right? Something between 1 and 6. And then let's just print it. Okay, so there you go. Right, I've created an array. I've walked through the array, and at every step into a box, I've put a random number. Right? We're treating like this, you can just treat as any other name. It's just sort of convenient to be able to like sequence a bunch of values in the same name. All right, exercise 2. So we have this value x's from the previous program. How now can I sum the numbers in this array? What's the sum of these numbers? We talked about summing last week with for loops, right? I used this word. What was the word I said is useful here? We want to accumulate something, yeah? We want to accumulate the sum of these numbers. I think we actually did a problem like this, but we had the user input the numbers we wanted to sum. Okay, but now the numbers that we want to sum are like inside this data structure. So any ideas what we can do here? So I want to accumulate something, right? This is going to be the answer essentially at the end. So I'm just going to say, okay, well, let's just print it. That would be the answer. But how do I actually now accumulate these things? What do I have to do? Like, you don't even have to tell me in Python. You can just tell me in English. Like, what is required of us to sum all the numbers in this array? Bare minimum. Yes, sir. Yeah, I have to look at every number in the array, bare minimum. Okay, so how could I look at every number in this array? First question, are the indexes in this instance meaningful? Do we need them? Do I? No, right? We just need the values themselves, right? The indexes are pointless. We can if we want, but we don't really need them. So what tool have I showed you that is going to allow us to look at every value in this array without having to generate the indexes? Well, there's while loops and for loops. Was it the while loop? No. So it was the for loop. So we say something like for x in x's. Okay. So we are going to look at all the x's essentially. Okay. So I have this accumulating variable. I grab the first number of the array. It's 5. What should I do with it? I will sit here in silence and make you feel uncomfortable until someone answers. Yes, miss. Yeah, I want to add it to the accumulator. How can I do that? Almost there. X equals X. So this, let's parse this. We're saying into the variable name act plus X, put equals act, this. Look at it, Eddie. I didn't know that until I moved. You're very close, but let's study this, right? Remember that we read equals as gets. Like I understand how this can, like, why you can construct it like this, because equal in mathematics, it doesn't matter. Like you can permute the sides. But remember, this is not equals. This is something called the assignment operator. And remember, we read it as gets. So this would read accumulator plus X gets accumulator. I don't, that doesn't sound right. So let's just do this instead. Okay. This now says accumulator gets the previous value of the accumulator plus X. Does this sound a little bit more sensible? Yeah. Okay. So let's run this. 348. That seems sensible. Yeah. So we should think about, is this a sensible value? Like, how could we like deduce using logic if this was like a sensible value? Like, how would we know that we should reject this? Yes, sir. Exactly. That's perfect, right? Like we know the answer has to be, like we're generating 100 dice rolls. The minimum sum therefore is 100 and the maximum sum is 600. So 348, it at least seems plausible, right? If we had like returned 1,000,000, then we sort of have to be like, okay, like something's wrong, right? There's an expression that says a calculator is only as good as the scientist who trusts the output from the calculator, right? So don't abandon your like critical reasoning when like using a computer, right? You have to sort of ask, like, does this answer even make any sense? Like I used to teach calculus, and we'd always have to like tell these students to like, when they answer a question, can you please ask yourself if like the question's answer is like not nonsensical? Like if I ask you to measure something's length and you say it's -4, maybe you should try again, something like that. So please, like when you generate something, because you're going to be doing scientific computation with Python soon, there should be a sniff test. That's what we called it. You know, when you open the fridge and you're like skeptical if something's edible, you sort of smell it, and if it's okay, you eat it, right? You got to do the same thing with your answers. Okay, exercise 3, probably the most difficult one in this sequence. Find the number that occurs most frequently in the list in the previous exercise. How can we do this? So just to prove to you, we have this. Which one of these numbers occurs most frequently? Okay, let's reason this. How could you do it with a pen and paper? What would you do? right? Because it's not good enough. Like you must understand how arrays work, right? That's sort of easier, right? I'm sure if I said, give me an array of 100 elements, you could do that. But the secondary thing is here, we have to be able to like problem solve, or think, I have the following tool set. How can I use this tool set to solve this question? And a good way of thinking about this is, well, how would I just do it, period? Right? How would I tell my little sister to solve this problem? And that's a good way of, like, how would I explain to like someone in grade 3 to get to solve this problem? Think about that. Okay, yeah, like, so we can have like 6 different accumulators, right? You have a piece of paper, you write down 1, 2, 3, 4, 5, 6, and you start looking through the list, and you're like, just make a strike on that list. And then afterwards, we see which column or which row has the most number of strikes in it. Okay, very good. One criticism. I don't want to write 6 accumulators, right? What happens if I said we're generating like numbers between 1 and 1,000? Then I'd have to like write 1,000 accumulators. So wouldn't it be, what kind of new tool do we have, right, that allows us to like have multiple stuff? Arrays. We don't need 6 accumulators. We need 1 accumulating array, right? That's sort of like the real point of today, right? We could have written 1,000 accumulators, but this is going to save us a lot of time. I'm not going to call it an accumulator. I'm going to call it a count. And I want this count basically just to be 6 zeros. And it's zeros on purpose because I'm using them to count stuff, and I want to start counting from 0. In this case, it's sort of, I don't really need to know the indexes, right? I don't care. The only thing I care about are the values themselves. So because I don't care about the indexes, I'm just going to walk through the array like this. So what I'm going to do here is I want to say, so remember, count starts from 0 and goes to 5. So in the 0th position, I want to count the number of 1s. In the 1st position, I want to count the number of 2s. And in the 3rd position, I want to count the number. Oh, well, you see my point, right? See how indexing gets a little bit hairy. So I want to say something like count at x incremented by 1. Okay, but this is not going to work for a variety of reasons. First of all, x's can be values between 1 and 6, right? And the last index in this name or this array is 5. Okay, so step 1, I have to reduce this by 1, right? 1s are going to get counted at position 0. 2s are going to get counted at position 1. There's one extra change that I have to make here, and it's kind of nuanced. Can anyone detect it? So all of these arrays are technically filled with floats. This sort of irritates me about NumPy arrays. So if I were to try to run this, I'm going to get an error. Oops, or I should have got an error. Oh, it works. Never mind. Okay, I was going to say we may have to put an integer value here, but sort of ran differently on my computer. Okay, that's only step 1. Okay, so what information do we have now? It says the number, like 1s were rolled 18 times, 2 were rolled 16 times, 3s were rolled 19 times. Right, so we can manually inspect this. I guess there's a tie. Let's just say that we'll produce the first one. So which dice roll was produced the most number of times? 3. Okay, but like I want to have that done by the program, not by us visually inspecting it. So we're not quite done yet. What do I have to do now? Right. Yes, sir. Okay, that's a good suggestion. So I'm going to say max frequency is the maximum number in my count array. Right, so I'll just demonstrate that max frequency gets 9. Whoops. Spelled it wrong. Okay, 19. Okay, now what? This is a good question because we have to like utilize all of our previous knowledge. We have a handful of minutes. Yes, sir. Precisely, but how? Good question. Yeah, it is a good question. Okay, in the interest of time, I'll do it. But this was good discussion. Like this is how you have to sort of program. You have to ask, like, before you start programming, you really have to figure out like, what's my strategy here exactly? And again, a good way of thinking about this is if you had like a 4-year-old or 5-year-old, someone who understood primary math, how would you explain it to them? So I know the max frequency. So actually, I just need to walk through the list or the array. In this case, I do need to know the array index. So I start from 0, I go to 6 exclusive, I count by 1, and I ask if the count at k is equal to the max frequency, then it is the case that the number k is the thing that occurred most frequently. So I'll just say that. K occurred most frequently. And since there is a tie in this case, we're going to get 2 prints. Right, so 2 phases, right? First, I generated the frequencies of all the numbers. Then I figured out which was the largest frequency. And then I like scanned through my list, right, to say which one of these actually contained that max frequency. Right, so you can study this at all. I'll just do the last one here. Where's my Fibonacci? Oh, I think I typed this in the wrong place. I'll just move this. That should have been here. Okay, you know the Fibonacci sequence? It's if you put like 2 bunnies on an island and they start mating, this is the model of like how many bunnies you'll have after a certain amount of days. It's very easy. The Fibonacci sequence is a sequence of numbers where each number is the sum of the previous 2 numbers. And the first 2 numbers are 1 and 1. So I'm just asking here, fill an array with the first 15 Fibonacci numbers. So in the last moments of this lecture, I'm just going to start an array. I'm just going to say, here's an array, fill it with 1s. I need 16 of them. I'm going to say 4k in this range. And this time I want to start at 2. And I want to go to 16 and I want to count by 1. And I want to say x is at k is equal to x is at k minus 1 plus x is at k minus 2. And every number is the sum of the 2 previous numbers. I will print this, and there you go. There is the sum. This is a list of the first 15 Fibonacci numbers. And this type of for loop, one where you have an array, a sequence of numbers, where the next numbers are actually some function of the previous numbers, is something that's going to become important very soon for you in Sci 1000. Right? This is how we sort of do computations in science, right? By iteratively going through something and calculating. Anyways, I'll see you next week. Have a good one. I'm attending the EdSTEM. If you have any questions, go enjoy a little bit of the sun before it goes away again for a while. Talk with you later. Bye, chat. I'll see you later. Thanks for showing up digitally. Bye-bye.